So guys, this is an introductory on UHF VHF repeaters. When you first get your ham license, one of the first experiences you're going to have is talking to other operators using VHF or UHF frequencies that you are licensed to utilize legally. Normally, when you have your bubble packs or your new ham radio and stuff like that, and you want to talk to each other, and if you're in line of sight, you got Mr. Orange here, wants to talk to Mr. Green. He could just go Simplex right to him. And Simplex is pretty much just going from radio to radio, point-to-point communications. So for the simplicity of this video, we're just going to utilize one band, and that would be VHF in the 144 megahertz range, and it's also considered 2 meter. I'm going to be repeating myself, so some of this terminology will sink in. Normally there's a band plan, and I don't think that's a Simplex frequency band plan to be used in that capacity. That frequency usually is reserved for repeaters, but that is a subject for another video. But for simplicity again, that's the frequency that I'm going to use, or simulate using. I'm actually going to use something else, but that's not important. So these two guys are talking Simplex. This is called Simplex, from radio to radio on that one frequency, and you're only using one frequency, transmit and receive. So this guy's going to transmit on 147 megahertz, and this guy's going to receive on 147 megahertz, and these guys could talk to each other. I won't demonstrate this right now. So the frequency on this is 147, and that's what I'm going to put into this Wuxon here. 147,000, and it's on there already, and that's going to be transmit and receive. There's no shift or offset. Test 5, 4, 3, 2, 1. So this radio is receiving it, and I'm transmitting with this, obviously, and this is a scanner, so it cannot talk back to me, but you get the picture. So when you have line of sight or within range, this is the preferred way of talking to each other using Simplex. You're bypassing the repeater. If you want to talk to a wider range of people that are out of your range, then you would use the repeater. But just for point to point, this is the preferred way of doing it. This is good radio operations. This here is a portable repeater that I've borrowed for this demonstration, and this particular gear is obsolete, but it's still useful, and I'm trying to find out if I could use it in the ham band, but don't know yet. I haven't played around with it, but I did set it up for this particular experiment here, or demonstration. I'm going Simplex, so this repeater is being bypassed. It's not used at all. So test 5, 4, 3, 2, 1. This repeater is not receiving this signal, and it's not being activated. So now with this scenario, you have the orange radio here and the green radio there, and now you have a ridge in between, a pretty high ridge. It's not line of sight anymore. Pretty much your radio's right here, there's the ridge, and here's the green radio on the other side. And VHF and UHF is line of sight only. It's just a straight line of sight, and it doesn't have the capability of going up, negotiating the hill, and coming back down again. So there has to be some sort of relay station in between to link both of these guys up, and that's pretty much the basics for a repeater. And this symbol here is an R with a circle around it, and that's the symbol for repeater on your disaster maps and stuff like that, incident command structure. And that symbol there is the symbol for an antenna. So what we want to do is, if the orange radio wants to talk to the green radio, how that is accomplished with a repeater is you got to program another set of frequency to negotiate that. So this radio is actually going to talk to the repeater, and the repeater is going to receive that signal, turn it around into its transmitter, and relay it back down to this radio here, and vice versa. It's going to go the opposite direction as well. So we figured out, or we got it planned to where it's going direct so far. 147 megahertz transmit and receive signal. Now you got the hill in the way. Here's both radios. Here I am transmitting, and this guy's not receiving anymore. there's an obstacle in between that ridge line there. So now we have to program our frequencies into our radio. In this case, to find out what the frequency of this repeater is to scan the airwaves and decipher what they're using to access it. That's one way. Another way is to just look it up on the web, and they'll have a lot of the repeaters listed on various websites. And another way is a publication that has a directory, repeater directory guide, and your local ham clubs in that area. That will tell you all the repeaters that are in play around your area. But in this scenario here, we're going to use this repeater. You already know what the frequency is and all that good stuff, so we have to tune our radios for that repeater. So here we have the receive frequency of this repeater is 147.600. Transmit from this repeater is 147 megahertz. It's the same frequency as these two guys here. So what Mr. Orange is going to do is tune his radio to this repeater, and so is Mr. Green here. So let's do that. And if you notice, you see that I've written here tone, the subaudible tone, the CTCSS tone, the PL tone, the CG tone, code guard. That terminology means the same thing, but usually in the industry we call it your subaudible tone, or CTCSS. And in this particular repeater, this one right here, it's programmed for 123 hertz. 123 hertz, if you listen to it, if it's amplified quite a bit, it sounds like a really low hum. But the radio themselves, they transmit that tone in such a low level that it's buried within your voice and noise and all that good stuff. And the radios themselves would receive it, but what comes out of the speaker is filtered out. So all you get to hear is just your voice and not that tone. So that is filtered out once the radio receives it, and it's just a filtering mechanism for it to decipher if it's going to be activated or not activated. So in the amateur VHF band, it's a standard, almost a standard, at least here in the United States, that that the frequencies are separated by a shift of 600 hertz. That term shift is the same as offset. Your primary frequency, your simplex frequency, is shifted up or down 600 hertz. Offset 600 hertz up or down, or shifted 600 hertz. The terminology is a little different, but it means the same thing. So for example, here you have 147 megahertz simplex for these two to talk, but if you want to talk to the repeater, you're going to shift the frequency 600 hertz plus, add 600 hertz to this number. So the receive frequency, which you are transmitting, you are going to transmit 600 hertz more than this here, and the repeater is going to receive it at 147.600. And if you notice, the repeater itself, when it receives that, is going to repeat it and transmit it right back out at 147 megahertz, which is our same receive frequency down here. And the access code will be 123 hertz. If this was UHF, the 400 megahertz range, the standard shift plus or minus, or standard shift offset plus or minus, would be 5 megahertz. That's almost a standard in actually all services, GMRS, hams, and public safety. VHF on amateur band is 600 hertz, but all the other services, it's a crapshoot, whatever's available. But for our purposes, we'll just stick to hams because that's what you're legally allowed to use in repeaters. So let's program this up. So here's the original radio that we were working on, simplex mode. Transmit and receive 147 megahertz. So we're going to program in the offset to access the repeater. So in this particular radio, you press menu and you look for shift or offset. So I'm going to scroll through the menu items here. There's offset. So this guy is calling it offset, and is already set to 600 hertz. Now I'm going to activate the offset either plus or minus. So on this radio, press up and it says shift minus D or plus D. Right now it's off, so it's going direct. Press menu, go up and down for plus, minus, off, plus, minus, off. And we want to go plus, so I'll leave it on plus, press menu and exit. So there you have it. 147 megahertz. Now I'm going to transmit, and notice the display is going to change from this frequency 147, which is receiving, and is going to display the transmit frequency 147.6, 147.0 receive, 147.6 transmit. Now if I go to my repeater here, let me transmit, see if it works. It's not activating the repeater. And my other radio is not receiving that frequency either. I didn't put in that access code, 123 hertz. So let's do that. Now if you notice on this Wuxon you have CTC, is just short for CTCSS. That's the subtone that we're talking about. You got R for the receive CTCSS tone, and T for transmit tone. And right now they're both set to off. You could independently put in those tones on either transmit or receive. Good practice is to do it on both, so it'll filter out any interference out there in the field. If there's a signal that's on the frequency of the receive frequency of the radio, it'll open up the squelch and cause all sorts of noise. But with the tone on, it needs that tone for the filters to open it up. So I'm concerned with just transmit. I'm just going to do transmit. So here's transmit, menu. I put in my tone and I press up button there, and my tone was 123 hertz. 123 hertz. I press menu, press exit, and the transmit is on there already. And you've noticed the plus sign on there. The plus sign meaning it's 600 hertz positive shift or offset. So this is ready to go. So now with the access tone dialed into it, the CTCSS or subaudible tone transmit code, 35 watts, I got access, and there's my kickback. So here's a better view. The repeater is activated, and I'm going to transmit into it, and it's repeating. And here's the power out, transmitting. And that delay is what they call a transmit hang up time. And that's what you hear, or what is referred to as a ka-chunk, because that's what it sounds like, an audible ka-chunk. It's a long one, believe me, but that's what it's referred to. Now let's see if Mr. Orange here could talk to Mr. Green over here using the repeater. Test 5, 4, 3, 2, 1. Test 5, 4, 3, 2, 1. Test 5, 4, 3, 2, 1. Now Mr. Orange could talk to Mr. Green using the repeater. So this is what happens. Mr. Orange here is going to transmit and talk, and he's going to go up the mountain on 147.600 hertz. That's the frequency that Mr. Orange is transmitting with the access code of 123 hertz. That's what it is, an access code. 123 hertz. So the repeater here is going to receive that, decode the tone, and it's going to say proper tone and repeat that traffic. So it's going to take your voice, whip it on out to its transmit circuit. So that transmit circuit is going to go downwards this way to Mr. Green or anybody else in this area here. And it's going to transmit 147.00 megahertz, which Mr. Green is tuned to, and he's going to listen to that traffic. And the same thing is going to happen on the opposite way when he talks. He's going to transmit 147.600 going this way. This will receive it and retransmit it back out down to Mr. Orange at 147 megahertz, access code 123. And that's pretty much what it is in a nutshell. So pretty much I demonstrated this whole chain of event in the confines of my garage here, because this is a fully functioning repeater. What you just seen here is not video magic. This is the actual equipment in one sitting here. So here's my radio here. There's the repeater. Test 5, 4, 3, 2, 1. It's receiving, and you can hear the scanner behind me go off. And usually repeaters are located, like I said, on high ground, high buildings, high hills, and it's inside an enclosed, locked building, shack, or sort of like big old canister that's really locked up and is a permanent installation. This right here is pretty much for emergency comms, you know, search and rescues, fires, something field expedient that you could deploy when you need more coverage in a certain area that don't have repeater coverage or very good repeater coverage. So this makes it convenient to deploy out in the field. This particular box here, it comes with another box with a deep cycle battery rather, and it could operate for a good 8 hours, 16 hours. And the newer models now, they have 2 radios instead of 1, and it's backed up by a solar panel. Sooner or later I'll reverse engineer this box for you and tell you exactly how it works, and kind of show you what it takes to build a repeater, and how it's out of the reach of lots of preppers out there, mostly all of them. This is more like for a ham club or some guy with deep pockets, and it's, to me personally, it's impractical for me to use. It's a big box to try to hide, and it's too heavy. But what we'll do is we'll dispel some truths and myths about what it takes to build a repeater and what you need in reality to make a good, efficient repeater, or something that would work out there in the field. I've seen some pretty awful builds on YouTube, and they don't do the long range test on it, and I just know that it's not going to work. But we'll get to that when time comes. Ultimately, we're going to build a Simplex repeater out of this ammo box there. Gorilla Geek, going 10-10.